Hey everybody, this is the notes for section 6.2, which is about rational exponents. That means fractional exponents. They are not as scary as they sound. We will be okay. So if a is a real number where n is an integer and n is greater than 1, the nth root of a is the same as writing a to the 1/nth. Okay? So if I have the nth root of whatever, it means the same thing as if I write a to the 1 over n. Okay? So that writing something in a radical is the same thing as writing it in a fraction exponent. Okay? This is a key here. If you can grab this and get this idea that those things mean the same thing, a lot of this will go a little easier. So convert to a radical expression and simplify. When it says convert to radical form, it means write it with a square root symbol. So let's do that. So 8 to the 1/3. 1/3 as an exponent means cube root. And then under there, I'm going to put a -8. Well, can I take a cube root of -8? Yes, it's an odd root, so a negative number is okay. Something times something times something makes -8. The cube root of -8 is -2. 81 to the 1/4. So that means it's the 4th root of 81. Can I find the 4th root of 81? Well, yeah. The 4th root of 81 is 3. Okay, let's try another. -100 to the 1/2. Now think about where that negative number is. That negative technically, if we think about order of operations, multiplication comes after exponents. So what I really have here is this, okay? So I'm going to leave this negative out here. I'm going to apply my square root because that's what a 1/2 exponent really means. Can I do this? Absolutely. The square root of 100 is 10, and the negative applies to it, okay? This is different than this because now the negative is contained inside the parentheses. It's attached to that 100. So what that says to me is I'm finding the negative square root of 100. Can I do that yet? No, it's not real. All right. Now, this means something different, right? Do you remember what a negative exponent means? So if I have a to the -n, what that means is not make a negative. It does not have anything to do with the sign of the thing being the base, the a. What it means is flip, okay? So a negative exponent says the same thing every time. It says flip. If it looked like this to start, we'd flip it the other way. Okay, when you do the flip, the negative leaves the exponent. That's like the button you push to make the action. Once the button's pushed, it's gone. Okay, so let's think about this one in two pieces. This is really 16 to the -1/2, right? So I'm going to deal with the negative first. I'm going to make that 1 over 16 to the 1/2. Okay? And then from here, the 1/2 power is the same thing as a square root. So I'm going to make that 1 over the square root of 16. And the square root of 16 is 4, so that just makes this 1/4. All right, you try these. If you get stuck, drop them into the discussion, okay? These are all things we just did. All right, so then it says, let a be a real number and m and n be positive integers, such that m and m have no common factors. So they can't be like 6 and 4, they can't both be even. If the nth root of a is a real number, then we can think about this a to the m over n in pieces. So I can think about that as a to the 1/nth times m, and turn that into the nth root of a to the m. Or I can think about it in reverse. I can do a to the m to the nth root, which would be the same as the nth root of a to the m. Either way, this is fine. This will make more sense in a second. What it's telling you, though, is that if you have a fractional square root, right, a number m over n, m is the power. M is like the squared. N is the root. I can do those in whatever order I want. Sometimes it makes more sense to do one of them first because you get a prettier answer, right? So let's see how that actually goes. So this is 8 to the 2 over 3. Basically what this is saying is 8 squared to the third. Or I can think of it as the third squared. These are the same. These are both acceptable. So now we just have to think about what would be easier to do first. Is it easier to take the cube root of 8 first? Well, it might be, actually, because 8 has a nice cube root. So I'm going to use this path. So let's think about that as the cube root of 8. The cube root of 8 is 2. 2 squared is 4. Fine. Same thing would happen, though, in this spot. 8 squared is 64. The cube root of 64 is 4. Same path. Sometimes they both work out really easy. Sometimes your brain likes one way better than the other. Whatever happens is fine. All right, so let's try this one. This is 100 to the power of 5 divided by 2. Personally, I don't know or really want to, like I do, but I don't really want to take do 100 to the 5th, right? And then try to find the square root of that. But I know the square root of 100, so I'm going to do it in this order. So I'm going to take the square root first, and then raise that to the power of 5. So the square root of 100 is 10. To the 5th power is the same as 1, 2, 3, 4, 5. 100,000. All right, let's try this one. 1 over 25 to the power of 3 over 2. Here's the thing. If I do this, let's try the two paths. I can do 1 over 25, take the cube root of that and square it. Or I could do, oh, sorry, I did that backwards. Square root of that and cube it. Square root of that and cube it. Or I could do 1 over 25 cubed, or sorry, yes, cubed, and then take the square root of that. Here's the thing, I don't really know if I want to take the square root of 1 over 75. That doesn't work out nicely, but 25 is a nice square, right? So I'm going to do this one first. So I'm going to take the square root of 1 over 25. That's 1 over 5. And then I'm going to cube that. Well, 5 times 5 times 5 is 125. And that's all it is. Okay? All right. So let's try this one. This is 4 to the negative 3 halves. So now we have 3 things to do, really. Because we have to think about that negative. I have to think about the power of 3, and I have to think about the square root. So I'm going to deal with the negative first. So the negative says flip. So I'm going to get 1 over 4 to the 3 halves. Now I'm going to think about that. I can cube it and then take the square root, or I can take the square root and cube it. I have 4 is a nice even square root, so I'm going to do that first. So I have 1/4. I'm going to take the square root of it, and then I'm going to cube my answer. 1/4, the square root of 4 is 2. So 2 cubed is 1 over 8. Okay? Step by step by step. Step by step by step. Don't go crazy, okay? This one says negative 81 in parentheses, to the power of 3 over 4. So let's see. That's cubing and then a 4th root. So now, here's the thing. So I have a negative 81. Let's take, I don't know, let's cube it. I don't really want to cube negative 81. That sounds no fun. So let's take the 4th root first, and then we'll cube that answer. And now right here we run into trouble, don't we? Because the 4th root of negative 81 is not real. And cubing it, multiplying it together 3 times, isn't going to make it positive. So it's never going to work out as long as I'm only dealing with real numbers. All right, you try those. This is a perfect place to pop into the discussion if you're not been in there very often. You know you need to be. So ask for help if you need it. All right, now we're going to go the other way. Or are we? We're going the same direction. We're going to write these in radical notation. This just has a variable in it, so there's nothing really to solve because I don't know what a is. I'm just going to rewrite it. So I'm going to write this, let's see, it's a to the 3 over 5. So it's the 5th root of a cubed. Okay? Or I could write the cube root or the 5th root of a cubed. These mean the same thing. However it makes sense to you to write it, write it. All right, convert each of these to radical notation. Assume all, okay. So 5 to the 1/3 is the same as the cube root of 5. Okay? X to the 2 over 3 means the cube root of x squared. As long as these guys are the same root, they're both cube root, I can mush them together. So that gives me the cube root of 5x squared. All right. I can, as long as the index here, this 3, is the same for both, that's fine. If one was a 4 and one was a 3, I can't mush them. They're not the same. All right, let's try this one. Now look at the y. Okay, that guy, that 1/4 is not applied to the 3, so the 3 just stays. 3 times the 4th root of y. That's it. Okay, let's try this one. Ooh. Negative 3/4 only applies to z. So what happens here? Z says the first thing z has to do is flip because of that negative, but the 9 does not. So the 9 stays in the numerator. I have z to the power of 3/4. Now let's rewrite that. I have 9 in the numerator, z cubed, and the 4th root. Okay? All right. Here are more for you to try. You can do it. I have faith in you. Practice. More practice, better math. All right, now we got to go the other direction. We are going to make rational exponents. So we're going to make the fraction. Okay? So this one is the 4th root of b cubed. That means I need a b. The root is always the denominator of my fraction. The exponent is always the numerator, so it's b to the power of 3 over 4. This one is the square root of 7a. So I'm going to leave 7a together because they were both under the radical, and a square root is just the half power. All right. This one is different, isn't it? That one, the a is under the radical and the 7 is not. So it's just 7a to the 1/2, right? All right, again, more for you to try. Try those just like these. Here are some reminders of some exponent rules. So remember, if I have a to the m times a to the n, I add the exponents. That's like saying 2 cubed times 2 squared. That would get me 2 to the 5th. If I have them divided, I subtract the exponents. So if I had 2 cubed divided by 2 squared, that's like saying 2 times 2 times 2 divided by 2 times 2. Those guys would cancel. I would just have 2 to the first. Power to a power is multiply, so 2 cubed to the power of 2 would be 2 cubed twice. That'd be 2 to the 6th. I can distribute exponents only if there's no addition or subtraction sign. So I need an eraser because that was not what I meant to write. So if I have 2 times x, that thing squared, I can write it as 2 squared times x squared, or 4x squared. Same thing with division. So if I have 2 over 5 to the power of 3, I can do 2 to the third over 5 to the third. Okay? In addition, negative exponents we have been seeing all along. It means flip. Okay? Anything to the 0 power is 1. Anything to the 0 power is 1. Negative a million to the 0 power is 1. 5 to the 0 power is 1. Anything to the 0 power is 1. Okay? All right. So now let's use our properties to simplify some stuff. These are the more complex ones. I love these though, because they're very satisfying. All right, so we can do this a couple of different ways. For me, I think it makes sense to think about, because they have common denominators, I can add the exponents, right? 2/5 plus 3/5 is just 1. So really, this is the same as y to the first. All right, here I can subtract. So I have 6, a negative a half minus 3/2. So I have 6, negative a half minus 3/2 is negative 4/2. Negative 4/2 is the same as negative 2. And I need to rewrite it with a positive exponent. So a to the negative 2 says flip the a. So this turns into 6 over a squared. All right. Whew, this one has a lot going on. So let's first give everybody that 4 so we can break up the parentheses. When I do this, s to the half times 4, think about multiplying fractions. Half times 4 is the same as half times 4 over 1 gets me 4 over 2. Okay? So s becomes s to the 4/2. T, oh, I need the actual fraction bar, becomes 4 over 3. W becomes 12 over 4. And then let's simplify. S becomes s to the squared, because 4 divided by 2 is 2. T, I'm just stuck with 4/3. W, 12 divided by 4 is 3. And that's as far as I can get with that. That's just what's left. All right. Here are a couple for you to try. You will be okay. All right, one last thing. Suppose that P dollars in principal, a certain amount of money, is invested in an account that earns interest annually. This is what we do with those fractional exponents. After a certain number of years, your investment grows to a certain amount in dollars, and this is the rate of the return. So find the annual rate of return on $5,000, which grew to $6,894 dollars after 6 years. So all you are going to do is plug in the numbers that you are given, okay? This is P, this is A, this is T. So I have R equals 6894.21 divided by P to the power of 1 over 6 minus 1. You have a calculator, right? You do. You should get an answer as R equals 0.055. As a rate, as a percent, that would be 5.5%. If the bank gives you 5.5% on an investment, you should take it. All right. This is another example of the same kind of thing. This is the formula for the radius of a sphere. If the volume is this, what's the radius? Plug in volume for B. You know what pi is. Pi is 3.14. Find the volume, or sorry, plug in the volume, get the radius. You should get a radius of 3 inches. Okay, this is the end of this section of notes. I will see you in 6.3.